Hello, in this video I want to solve a oligopoly, actually a duopoly, a Cournot equilibrium problem. So here we are considering two firms. So again, there's only very few firms, so this is an oligopoly. And when there's only two firms, we call it a duopoly. And these two firms compete against each other in a market with the following market demand function. Q equals 1,000 minus 1,000 P. Each firm's marginal cost is constant at 0.28. And the question is, what is the Cournot equilibrium? Well, what we have to do here is realize that whenever one firm makes a choice of output, they have to take the other firm's output level into account. Right? So this is going to make the problem strategic in that we always have to think about what the rival will do when we act. The approach to solve a Cournot equilibrium problem is to find the best response function for each of the two firms, and then we solve those two equations simultaneously. So that's going to be what I'm going to be doing right now. All right, so I'm going to do a few steps here. First, we have to recognize that total output in this industry is given by output of firm 1 plus the output of firm 2. All right, I'm going to write the inverse demand function. So I'm just moving P over to the other side. So P equals 1 minus 0.001 Q. That is, I'm just solving for P from the market demand function. And of course, that is equal to 0.01 Q1 plus Q2, because Q equals the sum of those. And in fact, I can just go ahead and write it out. It says 1 minus 0.001 Q2 minus 0.001 Q1. And if I were to put the first two terms in parentheses like this, what I'm having here is what we call the residual demand. So the intuition here is that each firm look at the residual demand, which is the demand left over after the other firm has already decided how much to produce, and then the firm takes this residual demand function and chooses to produce the profit maximizing output level, which is always found where marginal revenue equals marginal cost. So the next step I have to do is to find what the revenue function is. So I'm going to focus on one firm. Of course, these two firms are identical in this example. So if I can find one firm's best response function by symmetry, I have already found the other firm's best response function as well. So for firm 1, the revenue is going to be equal to the market price times the quantity that they are producing. And we now know that the price is equal to this expression, and then I'm going to multiply that by Q1. Well, let me just be very careful about here. So we have 1 times Q1 minus 0.001 times Q2 times Q1 minus 0.001 Q1 squared. All right, from here I can then find the marginal revenue function for firm 1 by taking the derivative with respect to Q1. So we get 1 minus 0.001 Q2, and if I put that in parentheses, that's going to be the intercept, and then of course we have twice the slope in terms of its own quantity. All right, I'm going to set that equal to, so I'm going to set marginal revenue equal to marginal cost, which gives us 1 minus 0.001 Q2 minus 0.002 Q2 equals 0.28. That is 0.002 Q1 equals 1 minus 0.28 minus 0.001 Q1. Next, I solve for Q1 here, and when I do that, I'm going to be getting the firm's best response function. So what we have here is a function that tells us what firm 1 should be producing given what firm 2 is producing. I'm just going to simplify this a little bit. So if I just divide everything by 0.002, I get 360 minus 0.5 Q2. Okay, so again, this is what we call the best response function for firm 1. So, and by symmetry, as I mentioned earlier, firm 2's best response function will be exactly the same, except that the Q's are reversed from each other. And the next step is to solve these two equations simultaneously. So I'm going to go to the next page to do that. All right, so again, I'm going to rewrite it. Q1 equals 360 minus 0.5 Q2, and Q2 equals 360 minus 0.5 Q1. These are the best response function. I'm going to solve them simultaneously, which is, I'm just going to say I can find Q1, 360 minus 0.5, and I'm going to substitute the equation for Q2 into the first equation here, and we get this. Q1 equals 360 minus 180 plus, you have to be careful with the sign right here, 0.25 Q1. I'm going to move the Q1s over to the other side. So we have 0.75 Q1 equals 180, and therefore Q1, and this is going to be the equilibrium quantities, I'm just going to write a star on top of there, is then 180 divided by 0.75, which is equal to 240. Going to then find the equilibrium quantity for firm 2, and we know what that is. That's 360 minus 0.5 times the equilibrium quantity of firm 1. So that's just 360 minus 120. So that's also equal to 240. All right. The next step I would like to do, I don't know what step I'm on. Maybe it's 6. I'm just going to go ahead and find the market demand, or market price in equilibrium. So that's going to be 1 minus 0.001 times Q, which is Q1 plus Q2. So I have to add those two up, and that gives us 1 minus 0.48, so that's going to be 0.52. And then I can find each firm's profit. You take the price minus the average cost, and remember here that the marginal cost is constant, and therefore the marginal cost equals average cost. And then multiply it by the quantity produced by this firm. So that's equal to, I calculated that before, 57.6. And by symmetry, firm 2's profit is also equal to 57.6. All right, so now we have actually found all the equilibria that the Cournot equilibrium. We know the quantities, we know the price, and this is not strictly speaking necessary, we also know what the firm's profit level is. I just want to do one more thing on the next slide, which is to see whether the firms have an incentive to change their output level at this point. Okay, so the question is, do the firms want to depart from this Cournot quantity? So we know that Q1 equals 240 and Q2 equals 240. The market price right now is equal to 0.52, and each firm is making 57.6 in terms of profit. All right, so the question is, would a firm want to change what they're doing? So let's just of course. If we just think about it, the whole point of the Cournot equilibrium is to find an equilibrium such that no firm wants to change its behavior given what the other firm is doing. Right? That's the definition of a Nash equilibrium, and the Cournot equilibrium is a form of a Nash equilibrium. But let's just for fun, we'll suppose that firm 1 decided to produce one more unit in an effort to make more money. All right. First we have to find what the new price will be when they produce one more unit. It's going to be a slight fall from 0.52 to 0.519, and then will the firm make more money in this case? So we recalculate the profit, which is price minus average cost times the quantity. If I calculate that, it becomes 57.599, which is less than 57.6. So therefore, no firm has an incentive to change what they're doing, and therefore this Cournot equilibrium will be stable. All right, thank you very much.